An introduction to logarithms. So we have an exponential graph, 2 to the power of x, where the base is 2. The line y equals x. We're going to reflect the exponential graph in the line y equals x. The resulting graph is called the log graph to the base 2. Any graph reflected in the line y equals x, or any function reflected in y equals x, gives an inverse function. So if this is my exponential function, then this is the inverse function, the log function. The exponential function goes through this point, so it cuts the y-axis at y equals 1. If we were to reflect that point in this mirror line, so we've got this, and you can see that point on the inverse function graph, on the log graph, is at x equals 1. So when x equals 1.2, then y is equal to 2 to the power of x. X is 1.2. So y is equal to 2.2974 rounded. Now what if the y coordinate is given, but the x coordinate is unknown? So the y coordinate 2.2974 is equal to 2 to the power of x. What's the value of x? This is where we have to use the log function. On the log graph, we start here, 2.2974. We go to the graph, we come along here, and we're trying to work out this value. This will be the solution to our problem, and hopefully that will turn out to be 1.2. So y is equal to the logarithm to the base 2, that's what we were using in the original exponential function, base 2. So on the calculator, we want this function, log, base 2, and that's a rounded value, which gives us 1.2. So the value here is 1.2. So 2 to the power of what gives 2.2974? The answer is 1.2. And that's what logs do. When you have a problem where you're looking for the power, then logs can be useful to work out what the missing power is. So if the base is known, but you just have an unknown power, we use the log function. It's basically an inverse power function. It sounds complicated when we say logarithm or logs. It's just powers, but we're looking at inverse powers. So if we have y equals a to the power of n in exponential form, where a is the base, to work out the power, we can write this as the power is equal to log exactly the same base a, to what value for y. So this is the log of y to the base a. Just like here, we've got 2 to the power of 5 is 32. So if this was unknown and we were looking for what 2 to the power of what gives 32, then the log of 32 to the same base here, to the base 2, if you put that into your calculator, it will give you 5. It will give you the power. So logs are good for working out unknown powers. 10 to the power of 3 is 1000. Again, if this power was unknown, we can do this on the calculator. We can do the log of 1000 to the base 10, and the answer will be this unknown power here. Now base 10 is a common base, so sometimes we don't write it in. So if you see log 1000, then the base there is 10. So if the base is missing, it's usually 10. In word form, the conversion is like this, and these are equivalent to each other. So you might have something in exponential form and for the solution to a problem, it may be easier to write exactly what you've got but in log form. Or you might have something in log form and you want to write it in exponential form because it's easier to solve a problem when it's in exponential form. Example 1, we have to convert these three exponential forms to their equivalent log forms, and we have to convert these two log forms to their equivalent exponential forms. To evaluate the log of 81 to the base 3, yes, we could put it into the calculator, but let's say we were going to try and do this without using a calculator. So if I let all of this be equal to x, and then rewrite this in exponential form, so we have base power 3 to the power of x is equal to whatever's left over, 81. So 3 to the power of 4 is equal to 81. The log of a to the power of 6 to the base a. Again, if I let this be equal to x, then in exponential form, that's my base, that's the power. So a to the power of x is equal to whatever's left over, which is a to the power of 6. Now you have the same base on each side, and you have a single term on each side, so these powers must be the same, so x is equal to 6. There are various log functions on the calculator. We have this one here, log, and that one uses base 10. We have this one here, and this one you can set any base you like, any base. But the conditions on the base are the same as the conditions on the base for exponential functions. The base has to be positive, and it can't be equal to 1. And this log function here, it uses e as its base. So instead of saying the log of some value, I don't know, like 18 to the base e, we just shorten this because log to the base e is a very common log function. We could shorten it to ln. This part is shortened to ln, then just ln 18. So if you see this written somewhere, you know, okay, that's log of 18 to the base e. For practice, try these questions.